Hello and welcome to Cornerstones of Math. In this video, we are going to solve the following problem. The quadratic equation x squared minus ax plus 3a equals 0 has two distinct real roots, and the sum of the absolute values of those roots is square root of 13. What is the value of a? Here we are going to use the famous relation between roots and coefficients of a quadratic equation, which is also called Vieta's formulas. But before we get to that, let us first take a look at one condition first, that the given quadratic equation has two distinct real roots. This means that the discriminant is positive, so we have a squared minus 12a, and this must be positive. So we have a minus 12 is positive, therefore we have a is greater than 12 or a is less than 0. And this inequality is our first condition about a. Now let's move on to the relation between roots and coefficients part. Let alpha and beta be the two roots of the given quadratic equation. Then by the relation between roots and coefficients, alpha plus beta is a and alpha beta is 3a. So this is our second condition related to a. Now we move on to another given condition, that the sum of the absolute values of these two roots are square root of 13. So we have absolute value of alpha plus absolute value of beta equals square root of 13. Now we have to somehow use these. In order to do that, let us square both sides. Then we can delete some of these absolute value signs. Then we have simply alpha square and beta square, and 2 times absolute value of alpha beta, we need an absolute value sign here, equals 13. Now this part can be written as alpha plus beta square minus 2 alpha beta, and we have 2 absolute alpha beta equals 13. Now we use these conditions. So we have a square minus 2 times 3a plus 2 times absolute value of 3a equals 13. So we have a square minus 6a plus 6 absolute value of a minus 13 equals 0. So the conditions containing alpha and beta are now expressed as the condition with only a. Now let's divide the cases. When a is positive, a square minus 6a, then plus 6a minus 13 equals 0. So we have a square equals 13, and since we have a positive a condition here, we must choose only square root of 13. However, previously from the discriminant condition, we have already obtained this condition, and square root of 13 does not satisfy this range. Therefore, this value is invalid. In the next case, where a is negative, now this part becomes minus 6a. So we have a square minus 12a minus 13 equals 0. And if we factor this, we have a plus 1, a minus 13 equals 0. And since we have negative condition here, we only have to choose a equals minus 1. And this value actually satisfied this range obtained from the discriminant condition. So this value minus 1 is a valid one. Therefore, the only possible answer is a being minus 1. And that's all for today's video. Thank you for watching. And please like and subscribe for various interesting math problems. And I will see you in another video.